Hello, welcome to today's screencast, third in the series of gaseous exchange screencast. A quick recap on what we've been first. We've looked at gaseous exchange at rest, both at the alveoli and muscle tissue. Then we had a look at gaseous exchange and how it changed at exercise at the alveoli and muscle tissue. And our final small topic is going to have a little look, a deeper look, I suppose, into gaseous exchange at the muscle tissue during exercise. Now, just to make it a little bit more complicated, there is an additional part of the specification that asks us to have an understanding of the changes in dissociation of oxy-haemoglobin during exercise. Now that looks like it is going to be really, really complicated. So what I'm going to do is break it down very simply and then show you how you answer a question on it. So if we have to understand the changes in dissociation of oxy-haemoglobin during exercise, what do these words mean? Okay, first up then, section. Dissociation. All dissociation means is diffusion, which we've already talked about, or removal or unloading. Okay, dissociation. Oxy refers about oxygen, obviously, and then we've got hemoglobin, which refers to hemoglobin, but we're going to just simplify that to the blood. Now, once you put that together, I think if you summarize what the specification is asking you to be able to do, it's asking you to be able to say, why does more oxygen diffuse? I've used diffuse here alongside dissociate from the blood into the muscles during exercise. Now they've used some fancier words or more scientific words than say you would in a normal gaseous exchange question, but all it's asking you, this part of the spec, when you see dissociation, oxy-haemoglobin, when you see that, it's just asking you, all right, why does more oxygen diffuse from the hemoglobin or the blood into the muscles during exercise? Now that's a little bit more simplistic, okay? So we already know some reasons, but what we have to understand within today's focus is there are some additional reasons above diffusion gradients that more oxygen diffuses into our working muscles during exercise. So let's have a look then. So if we start off then, the question into here, I'll just go back very quickly. Why does more oxygen, so we use that same question as I put down to there, why does more oxygen dissociate from the blood or hemoglobin into the muscles during exercise? Now what we know is that there is a steeper oxygen diffusion gradient during exercise. So more O2 diffuses faster from the blood into the muscles. I'm not going to go into massive detail because you've just done this recently, but we know that there's a lower PPO2 during exercise in the muscles, and we know there's a high PPO2 in the blood here. So that causes a steeper oxygen diffusion gradient. So our previous knowledge will tell us that more oxygen dissociates from the blood or hemoglobin into the muscles because there's a steeper oxygen diffusion gradient. On top of that, because the two gases always are working together, another reason that more oxygen diffuses in is because more carbon dioxide diffuses the other way. So you can also get a mark for saying there is a steeper CO2 diffusion gradient because we've got a higher ppCO2 in our muscles and a low ppCO2 in the blood. This means that there's a more and faster CO2 diffusion goes into here due to the steeper diffusion gradient. Now because more goes out of there, this allows space for more oxygen to come in here, as we've talked about there, so you will always get a mark for talking about the two diffusion gradients at the muscle tissue here. So that is previous knowledge. So when it asks you very simply about this, we already know that the muscle tissue has a different or steeper diffusion gradients because of the higher and lower partial pressures of oxygen and carbon dioxide here. So that's we already know that. So when this question comes up in the exam, there are two additional points we have to know. And I think you'll understand. I think it'll make sense. So the reason why more oxygen dissociates from the hemoglobin or the blood here into the muscles during exercise is because when we exercise, there is an increase in blood temperature. Okay, so when the oxygen is carried down into here, there's a high partial pressure of oxygen, it gets really hot during exercise. And because the temperature increases so much, oxygen cannot handle the heat of the blood or hemoglobin. So because it's so hot, the oxygen has to diffuse or dissociate into the muscles. So imagine it's scalding hot in that blood and the oxygen just can't cope with that. So the other factor, the other reason why more oxygen dissociates from the blood into the muscles is because there is the temperature increases in the blood, okay, causing more O2 to diffuse or dissociate into the muscle tissue. Now there's one other thing linked to the blood when we get to this point, okay. So if we look at it from here, the other reason more oxygen dissociates from the blood into the working muscles is because of the acid levels in the blood. blood. So when you're coming down here, the blood, when it's exercised, as we know, it starts to become extremely acidic in this blood, and there's different acids. Now I will give a couple that you might not have heard of. The carbonic acid becomes extremely high, and what you might have heard of, lactic acid. So because there is an increase in blood acidity, for example lactic acid, because the acid level is so high, the oxygen cannot cope in there. Okay, the exercise is making acid level go up in the blood, and the oxygen's thinking, I can't cope with this. I've got to get from the blood into the muscle. Okay, so an increase in blood or blood acidity increases, lactic acid, for example, causing more oxygen to dissociate, to get off, to remove, to unload, to dissociate, to diffuse into the working muscles. Okay, so that is the key 4 factors that cause more oxygen to dissociate from the hemoglobin into the muscles during exercise. Okay, so we have a very specific question that we're going to get for this: oxygen dissociation from hemoglobin, oxy-haemoglobin dissociation. They'll be the things you're looking for in the exam question. So let's have a look then. If that's your basics, when you see that question, that's what it's talking about. Now, just to add a slight layer of complexity to this, when you have a question on oxy-haemoglobin dissociation, it is often this relationship that happens at the muscle, okay, between the muscle and the blood during exercise, hemoglobin, oxy-haemoglobin dissociation, is depicted by a graph. Okay, the graph could be confusing, but hopefully I can make it extremely simplistic for you. So the oxy-haemoglobin dissociation curve, basically, if I just take you through this, if we have a look, it refers to how much oxygen is saturated or I suppose associated to hemoglobin. So at rest, this black line here, all this is saying is at rest there is a high association between oxygen and hemoglobin. Now during exercise, if you can see the dotted line here, I think it would be a really good idea for you to draw this. This is what happens to the oxy-haemoglobin dissociation curve during exercise. So this bit here, because the oxy-haemoglobin dissociation curve moves to the right, all that is saying is that more oxygen is dissociated into the muscle. Okay, so if that's oxygen and hemoglobin together on here, all this is just showing by it moving to the right is that more oxygen moves into the working muscles or dissociates into the working muscles. So that is just a curve that is used to depict what happens. We already know the 4 reasons why this curve shifts to the right, or more oxygen dissociates from hemoglobin. So if I just ask you to write these key things down, it's just a bit of a recap really, so that if you got a question that showed you a curve and said what happened to it during exercise or the oxy-haemoglobin dissociation curve, all you need to say is that it moves to the right. Okay, why does it move to the right? What does that mean? It just means there's more oxygen dissociated from hemoglobin to the muscles. Why? We know there's a temperature increase in the blood acidity increases, steeper CO2 diffusion gradient, steeper O2 diffusion gradient, and all of these increased amount of oxygen that dissociates from hemoglobin into the working muscles. As you can see, I'll put that into this section here. So that is just looking at it from the graph point of view. And the final thing I'm going to do, just so I can imagine some people now thinking, yeah, I get the process at the muscle tissue during exercise, the blood temperature increases, the acid in the blood increases, those 2 things particularly cause oxygen to dissociate more readily into the working muscles. I think people will get that. We already know there's a CO2 and O2 diffusion gradient that's steeper during exercise, so we know that that's a reason why we're going to get more oxygen dissociating into the working muscles. So that would seem pretty straightforward, but I understand sometimes it might think, well, it's quite a bit extra on top of our 2 gaseous exchange topics so far. So if you're in that situation, what I'm going to do is just give you an option now to use this as a way to remember it. Now, for example, I'll put onto the graph here, okay, so I'll put down, if you want to look at this bit here, so oxy-haemoglobin dissociation curve means right during exercise. This means more oxygen. You've already wrote it, so you don't have to write it again. Just listen for now. More oxygen dissociated from hemoglobin to the muscles. Why? Okay. Now, what I want to do now is when you see, if you saw this in an exam, and it said the oxy-haemoglobin dissociation curve or oxy-haemoglobin dissociation, we need to know something that can help us remember it. Okay, so I've said here it means that more oxygen dissociated from hemoglobin into the muscles. Okay, what I need you to do here then is I'm going to give you a way to remember it. So when we're talking about oxy-haemoglobin dissociation, okay, during exercise, there's a couple of things that we have to know. It only takes place, this is only ever used, this term only ever comes up when it's talking about the muscle tissue or gaseous exchange of the muscle tissue during exercise. They are the two things that you know. This is when the big ones come in. Now, it should have the title in the question. I cannot believe it would never do that. But just know that oxy-haemoglobin dissociation curve is only ever referring to the muscle tissue during exercise. Now, that is a good way to help you remember it, because I think if you combine muscle, the M from muscle, to X for exercise, that would spell M plus X equals MEX. Now, once you've done that, you can turn the word MEX into Mexican. Now, what I want you to do is to stick with me here and think, right, Mexican. Let's think of a Mexican restaurant, and I'm going to give you a made-up Mexican restaurant. The name of this Mexican restaurant, it's the best Mexican restaurant in the world, if it existed, and it's called Dr. Taco. Okay, Dr. Taco, this is the place to go, and from there, the reason why I'm using this is because if you can create this chain, it will help you when you're answering, because what this is going to do, Dr. Taco is going to be abbreviated into DCR Taco, and that is then going to come down to here. So, in terms of why oxy-haemoglobin dissociation curve moves to the right, okay, during exercise, the dissociation curve moves right because of an increase in this, and steeper of these two. So we have an increase in blood temperature, we have an increase in blood acidity, we have a carbon dioxide diffusion gradient that is steeper, and an oxygen diffusion gradient that is steeper. All four of these mean that oxy-haemoglobin dissociation is increased during exercise. So more oxygen goes into the muscle cell when we need it, which means we can perform for longer. So hopefully, if the chain doesn't work for you, when you see oxy-haemoglobin dissociation, we've got to remember that it is TACO. Okay, TACO is the key there, but this is just if you've got the curve to help you with that section. Okay, make good notes on this. Thank you very much.